tell you a little more about the Labelbox connector on Databricks. This connector is part of our partnership where we make it easy for teams to take unstructured data sitting on the data lake and annotate that in Labelbox using our suite of tools for really quick, intuitive annotation. And then the connector moves the data back and forth so you can easily get your annotations back into your compute and analytics environment in Databricks. So just to describe how these tools fit together really quickly, if we look at this diagram, you can roughly separate AI activities into three main blocks. At the bottom, starting with data labeling and management. From there, once you get your data sets, you can create your initial models and train them and improve them. And then finally, when your models are ready, you deploy them into the wild. You can roughly separate the top two from the bottom one with this line here, where the top is your compute and analytics kind of workload, and the bottom is really focused on data creation, data curation, and data quality. So Labelbox is really good at managing your data, creating high quality annotations, and Databricks is really good at compute, training your models, and assisting with the workflows to deploy your models on downstream tools. So if you combine Databricks and Labelbox together using the connector, you can actually get a very productive environment for your data teams where you are taking your unstructured data, labeling it in Labelbox, getting those annotations into Databricks and your data lake, and running your model creation and model deployment on top of that. This is generally the workflow that we see a lot of teams following. They'll start with unstructured data sitting in their bucket storage or blob and browse through that data, find the information that they need annotated, pass that over to Labelbox for annotation. From there, Labelbox will produce structured annotations that describe what is in your images or your text or your video. And then we pass that back to Databricks through the connector. And from there, teams can build their machine learning workflows or query the data using SQL and derive analytics and insights from that data. You'll also notice that the machine learning workflow can connect back into Labelbox. Teams are able to take their models and pre-label the next set of data coming into the system, creating a model-assisted workflow. This model-assisted labeling creates a virtuous cycle where the model is producing the next set of annotations. Your humans are correcting those annotations for mistakes, and then you can retrain on those corrected annotations and produce an even stronger model while also reducing your labeling time and saving you money. So today I'm going to show you a quick demo of how all these tools work together, and we'll hop right in to Databricks to get this started. Okay, so I'm in my Databricks environment, and the first thing I want to do is show you the data that I'm going to be working with. I have a Spark table here with a handful of image data listed. These are just URLs to images sitting in my data lake. They happen to be sitting in my Labelbox storage account, but they could be stored in AWS, GCP, or Azure. We have full delegated support for those three major storage platforms. And we'll take a quick preview at some of these images here. These are just standard photos of people walking around on a street. Some of the images in this data set show cars driving by. They have different kinds of weather conditions, daytime and nighttime photos. And let's say that we are trying to create a data set to train a model how to recognize these different objects and also to recognize the time of day and the weather. So starting from scratch, all we have are the raw images. This is unstructured data. It's very difficult for machine learning to start with this raw data. We need to provide it with annotations so that it can start to understand what's in each image and learn. So what I'm going to do is create a Labelbox client using the Labelbox SDK. And I'm just going to pass this table of image URLs to Labelbox using the LabelSpark library's create dataset. Now, this is the Labelbox connector for Databricks, but just for simplicity, we've called this library the LabelSpark library here. So I'm going to run this command, and you'll see that the data set is created in Labelbox. So if I go to Labelbox, you'll notice that I now have this data set here in my gallery view. This lets me easily visualize the data set that I just shared with Labelbox. And I can even click into some of these images and look at the metadata associated with this. And I can even select a subset of images and create a smaller data set out of this larger data set. And this becomes much of a challenge when you're dealing with huge data sets with thousands of images, and you only want to find those 10 or 20 that are most relevant. So you can quickly browse through the gallery, pick those out, and then queue them for labeling. So our data set is registered in Labelbox, but we now need to create a labeling project. Now, this is something that can be done completely programmatically here from my notebook. You'll notice I'm going to create an ontology and add some tools like a bounding box tool, segmentation mask tool, and a polygon tool. And I'm also adding some classifications to my labeling project. So I'm going to ask my labelers to tell me the weather and the time of day. Now, the reason I'm doing this programmatically is to show you that you can do this all in code. This is especially useful for production workflows where you don't always want to go into a user interface to create these environments. So I'm just going to run this command, and in just a few seconds, we will create the project in Labelbox. So if I go back to my projects here and refresh the page, I can see my fresh created demo. So I'm going to click on Start Labeling, and immediately I have my ontology here on the left. I can see my bounding box, car, segmentation mask, umbrella, polygon tool, as well as those classifications that I just programmatically specified. So Labelbox is built for speed. Your professional labelers or volunteer labelers around your office can come in here and using the keyboard and mouse, just really quickly start annotating these images. I'm going to really quickly mark these. It's the daytime shot under clear conditions. I don't see any umbrellas in this scene, nor do I see any cars. So I'm just going to go through and submit this label. Now, Labelbox has a very robust queue manager that will distribute the work to your labeling team. In this demo, I'm the only person labeling this project, but you can have dozens, even hundreds of people working on a labeling project. And that's how you can really quickly get large data sets annotated for your machine learning tasks. So I'll just keep on labeling this data set. You kind of get the idea. Let's keep going until we encounter a car. I'm going to skip. There we go. So there's a car. I want to show you the use of the segmentation mask. Here I have a pen tool, which allows me to draw just using straight lines if I want. And you'll actually find that going point to point gives you very good fidelity for most use cases. But for very detailed use cases where you need to get pixel perfect, we do have freehand drawing. With my mouse, it's a little bit difficult, but you can zoom in and iteratively add to your mask, and over time build that pixel perfect segmentation mask for your model. This is particularly valuable if you're trying to train a model how to recognize and draw masks over specific objects. So I'm just going to finish this up really quick here. And I could see here I missed a little bit of the car, so I'm just going to draw that line and close that polygon there. And now I have a very, very rudimentary layer mask over my car. The segmentation tool also has subtraction. The Labelbox has a handful of tools to make it very quick and easy to get accurate annotations here. And we also have a guided tool called SuperPixel that will analyze the image and use contrast to try to outline where objects start and end. So this is pretty useful for quickly finding edges. You could see it actually isolated out my car pretty effectively. In this case, a lot of the ground and subjects are all gray, so it is not going to have the best performance here, but you can actually see it is able to pull out the background from these subjects here pretty effectively. I'm just going to remove these really quick and get out of the SuperPixel tool. So there's my car. That's just one car. There are actually a few here, so I could just click on my car tool again, draw another segmentation mask, and create those additional cars at any time. But for now, I'm just going to submit and get this label out for my data team. So your data team would progress through and ultimately create your fully labeled data set. Now, you're probably curious about how it looks when it comes back into Databricks. So what I'm going to do is using a project that I've already completed, I'm going to call the get annotations method with the project ID. And this will call the Labelbox REST API and pull in all of these annotations for us. So you get some information about the annotation. Each row corresponds to a specific image. And in this case, you can quickly see that this image has a handful of classifications. It's got a bunch of objects in there. The bounding boxes actually come with the X and Y coordinates. You get the color of that bounding box, as well as a URI back to the object. So if I actually loaded this into my browser, I would just get this grayscale image, but it shows me where that specific bounding box is. So this is useful for your AI and machine learning models downstream. They can refer to these grayscale images to identify where your objects are on the frame. So this is all pretty good. We have the raw JSON in this Spark table here. You can easily save this as a Delta table. What I'm going to do here is just refine this table a little more, where I'm going to flatten the table out, where now I have all of my classifications and objects in separate columns. So, if you're a programmer and you're just trying to get data out of these data rows, this flattened table makes it very convenient to do that. So I can quickly, at a glance, see all the different responses for the classifications here. All of the bounding box coordinates are in this very nice array, so I can access that information programmatically. Most users don't need the information like this. This just helps with downstream development and engineering. We also have a silver table method that takes in the bronze table and refines it a little bit further. So we actually will parse out the classifications into their own columns, as well as count the objects that are in each image. Or if you're looking at a video frame, you can get the count of objects in each frame for video. In this case, we have different numbers of people, cars, and umbrellas. And we go through and just provide a basic count of all those objects. If I go a little bit farther to the right here, you get the same flattened information from the previous table. And then you'll notice here, I actually get a list of all the URLs to the layer masks for the bounding boxes and segmentation masks in my data set. So if I just load a random data set like this, a random URL like this, I'll get that mask and the bounding box right there. And you can always download these and store them in your system of record if you want. We also have some additional fields here on the right, like under the view label column, there should be a link back to the original editor view in Labelbox. So if I want to inspect that particular data row, I can just paste that into my browser and follow it back to Labelbox where I see the asset. And maybe I find a mistake. I want to correct this. I want to shrink this bounding box. I can easily do that, save that, and then commit those new annotations to my data lake. Additionally, this silver table makes it very easy for business analysts to query what was previously a set of completely unannotated, unstructured images. I had no idea what was in these images. If I wanted to find a particular image that satisfied some criteria, I would have to manually inspect all of them. But now I can just write the SQL query and quickly find that particular image that meets my criteria. And then if I want to verify that it does meet my needs, I can load that image into my browser and see that, yes, I found this image that has everything that I'm looking for. It's got rain, it's got umbrellas, people, and cars. I could take this and train my model to now understand those objects. Maybe I'm interested in images that have a lot of people in them, so I can search by the people count column here. And you'll see that I actually do have one sample data spot, a data point here with 48 people in it. So if I go here and load this labeled data into my browser, you can see there are quite a lot of people here. And this would be a very challenging data point for any AI model to tackle because there's so much going on in the frame. But what we're trying to do is make it easy for teams to find the images and assets that they want using Spark and SQL, and eventually to pipe this into their AI machine learning workflows.